Welcome GibbsCAM users. Today's video we're going to continue to focus on GibbsCAM 2025, and in this video we're going to go over two-axis turning. This is not MTM, that'll be on another class, but this is a beginning class on two-axis turning. So without further ado, let's get started. This is what we're going to be machining today. Just a two-axis part with some ID turning and drilling and some threading. And this is the blueprint here for it, and you can download this off the details page on the YouTube, and to get started you can see all the dimensions in there for that. So again, as we start working on this part, let's go up to File and New, and of course give it a name. We're just going to call this two-axis turning, and this should appear at the top of your page up here, two-axis turning. Now, if the last project you did was milling, this is what you're going to see on your screen. It might be a little bit different on the square, but you're going to see a milling part here, which we don't want. So before you go any further, make sure you go to Document Control and click the drop-down menu. Let's scroll clear to the top, and we're looking for horizontal lathe generic shank. Okay, we'll just keep this at aluminum alloys wrought. You can see all the different menus here for material. We're going to program in inches, of course, and diameter. So make sure diameter is checked, not radius. And the shank we're using is a 1-inch shank. That's your stick tooling. You can see the different sizes here. The most popular is 1 inch, of course. And before we get filling too much of this out, let's take a look at our print so we can kind of do this as we're looking at the print. So now that we have the print up, we can fill out some of these blanks here and over here. Of course, this does not have milling. This is just a two-axis turning part. So let's just click this first of all. Go down to None. Of course, 1-inch shank here. Now we have the clearance here and the Z clearance, but let's look at the part here first of all. So if we look at our print, you'll see it's 8 inches in diameter. That's the stock I want to use, so I'm going to put 8 inches in there. And then how much material do we want the front of the face to face off? I'm going to give it 1/8 of an inch there. Okay, and our Z minimum, so basically the length of our part, you can see on the print, is 7 inches. So I'm going to say minus 7.125. I'm going to give it 1/8 of an inch on the back side as well. Now we need to figure out how much we're going to grab onto with our jaws here, and if we look at our print, this is from 6 to 7, that's 1 inch, so I'm going to grab onto about 1/2 an inch of material, and if you figure there's still 1/8 of an inch material left on the back, we're going to grab it, so 1/2 inch plus 1/8 is 0.625. So we're going to grab onto 5/8 of the part, and then we need to know how much material is sticking out past that part, so we can do a little bit of calculation here. We know it's 7 1/8 inch overall from the back to the front there. And if we do a little bit of a calculation, we should have about 6 5/8 sticking out from the jaws to the front here. This doesn't matter too much on two-axis turning, but the visuals will be helpful on here, so we might as well get the numbers correct on here. Now, of course, over here we need to make sure we have the clearance bigger than our stock. Our stock is, of course, 8 inches here. So we want to make sure we clear the part when we wrap it to and from the turret home location. So I'm going to go 8 1/4 on the clearance on the diameter, and Z I'm going to put probably 3/8 there. That'll give us a little 1/4 inch there past the material. Everything there is good. We shouldn't need to do a tool change because most of the posts that Gibbs sends out, it returns to the tool change, the home position for the tool chain. So unless you have a really long bed and you don't want the tool to go clear to the end of the tool change, if you have a 60-inch long bed, you don't want it to go clear back there for changing tools. So you can change this, but for the most part, the post will send it to the home location. Okay, so all that looks pretty good. You can close this. And let's just do a no zoom there. And there is our part there. Now there's a couple ways to draw a part. We're going to draw this as geometry and not use a solid. The next class on the two-axis turning we'll be using a solid, and you'll see the big difference on using a solid and how much easier that is to use. So if we look at our print here, we'll kind of go through this. We're going to go bring up our geometry palette. And for the first part, we're going to use parametric programming. If you've never used parametric programming, for those that have run conversational lathes, that's usually how the shapes are drawn parametrically. So we're going to do that same thing in Gibbs. So the first thing we want to draw is a 90-degree line at Z0. If you press enter, of course, you'll see your line appear there. So now we're going to go up from the face and counterclockwise around the part. So the next thing we're going to encounter is a chamfer there. So let's click on this little icon here and click on chamfer, and that needs to be 1/8 of an inch. Next is going to be a 180-degree line at 2.5 inches. That's where our threads are. So now we're at that point there. So the next thing in line is going to be a 225-degree angle at Z minus 1.5 and 2.5 on the diameter. So now we're down at the angle there. So the next thing we want to do is a 180-degree line at 2.25. So far, so good. So the next thing in line here, we're going to do this little fillet here. So let's click on this drop down. So you could either choose a fillet or clockwise or counterclockwise. We'll just use a fillet there. And that needs to be 1/4 inch. Okay. So then we need a 90-degree line at -3 inches in Z. So now we'll have that going on there, and then it won't draw the fillet yet till we're up here. So let's do another fillet. And that also needs to be 1/4 inch. So we'll just press that. Next line is 180 degrees at 4 inches. So you can see our fillet has appeared now. So the next thing beyond that, next is a counterclockwise radius there, and that needs to be 1/4 inch and -4.25 and 4.5 on the diameter there. So now we're up to that point there. So the next thing we need to do is, of course, another fillet, but this is going to be a little bit bigger, and we're going to go counterclockwise there, and that needs to be 3/4 of an inch. And that looks like it needs to be at -5.25 and 4.5 inches. So far, so good. And next, 180-degree line at 6-inch diameter. Whoops, we needed 180-degree, not 280. Okay, 180-degree line at 6 inches. So next we have another, we're up to this point now, 6 inches. We need another 1/4 inch fillet in there. So let's just choose a fillet there. That needs to be 1/4 inch. And then we need to go from there, we need to go up in the Z. Get the Z first, then up. So that'll be at 90 and -6 in Z, which needs to be 270 at, are we -7 inches. So we have our backside there. We're starting to now do the backside. So now we need to get to the, start to do the ID of the part, which is going to be 1.25 inches. And let's see where we're at, 1.25 inches. So basically 0 degrees and 1.25 inch diameter there. Okay, now we need to put in the Z, which is going to be at 90 degrees and -1.19 on the Z. Okay, next is going to be 0 at 1 3/4. Okay, so now we have our shape almost drawn there. Now we need to connect up here. So to do that, just click on this last one here and click this connect button there. And if you look at your print and the part, everything looks like it's supposed to. It looks like we might have missed a chamfer on there, so let's go in and fix that. So even if you have that done, you can go back into here and put in the correct value, but on here we could just click on this corner and click the chamfer button, type in 1/8 of an inch, and there we have our chamfer on there. I think everything else there looks good. We have our chamfer, radius, 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 kind of a chamfer there, chamfer in the front, nothing there. So everything there looks good. Now one thing you can do, let's save this before we go any further, You can always open Geometry Palette again, and if you want to check your part or if you made a mistake, you can click this Parametric, or Gibbs calls it Geometry Expert, it's Parametric. And if you just double click your part, you'll see it fills in all the blanks of everything there. So if you messed up on something, maybe you messed up here, let's just see, if you click on it, it highlights it. And if I want to change it to say 0.300, you can see it changes it automatically there, but we need to go back to 1/4 inch, so make sure that's correct. But you can check anything there for diameters, fillets, whatever you need to see if you messed up there, and you can change it here. Okay, so that's one way of drawing the part. We're going to show you a second way now, using geometry and not using parametric. So in order to do that, we're not using parametric, of course. So I'm just going to hold the Shift key down and delete all the geometry there. So now we're going to draw it using just lines, arcs, circles, things like that. So first thing I want to do is pick line command, and from axis, and vertical lines. So the first thing I'm going to put in is the line at Z0. Make sure you pick the double line so it stays in that menu. So if you look at your print, our next Z is -3 inches. Then -4.5, -6, -7, and that should be all the lines except for the line we need to draw 1 3/8 down to here. So get out of this menu, pick line again, and this time parallel off of this one, 1 3/8. Make sure you pick this one closest to the front. So now we have all our vertical lines drawn. We should have 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, and 6 there. Okay, so now let's draw some horizontal lines. So again, line and horizontal. Let's pick the horizontal tab. And the first thing you want to do is 2.5 inches. We're just going to draw the outside first, so that'll make it a little easier. Make sure you pick the double lines there. Okay, next is 2 1/4 for the bottom of this one right here. Down here, 2 1/4. And you press enter again. And next one is 4 inches. Next one is 6 inches. Next one is 8 inches. So that should be all the OD lines we need. So if we count them, we have 1, 2, 3, 4, 5. So we should have 1, 2, 3, 4, 5, which we do. So let's start connecting some of these up first. But before I start connecting a lot of them, let's do this little chamfer here. Okay, so we can't put necessarily a chamfer there because the dimension comes from this corner. So I'm going to draw an angle up here. So I'm just going to hold Control and connect these two lines here. Just connect. That'll put a blue dot there that tells me it's connected there. Now I want to draw a line at an angle, and this needs to be at 45 degrees. And there we have our line. Now we don't really need this anymore. That was just a construction line. So let's delete that and delete that point while we're at it. All right, now we can finish up our outside there. So pick the point command only one time. Don't pick any other menu. Let's start with the Z0 and come up to these two lines. Make sure you press the double points to stay in that menu. From now on here, you can use the space bar. So let's click there to there, space bar, there to there, space bar, next, space bar, next. We're just gonna basically walk around the part there. And the last two there. Okay, good. All right, now let's draw the ID before we do the chamfers or anything else there. So let's start the ID. That'll reduce how many lines we have, so it's a little less confusing. So again, let's pick the line, and from axis there, and we'll do horizontal lines first. So the first one I need to do, let's start at the front, is 1 3/4. Press the double lines to make sure you stay there. So there's 1 3/4. Next one's going to be 1 1/4. And the last one, 2 1/4. So now we have our 3 lines. Now let's draw some vertical lines. Okay, the first one I want to draw is, let's see, we don't have dimension from the front, but we have the dimension from the back. So let's go back, pick line and parallel this time. Click this line at -7 inches and we need to go 3.258, 3.258, and we'll just draw one line there. And of course you want to pick this one. The next one back is 1.19, so we could do either line parallel or axis. We'll just do line parallel again. I guess we could have stayed in that menu. And 1.19, and there's that one. Now we can start connecting the ID up. So let's just pick the point command again. Don't pick any menu. Pick this line here and this one right here, and pick the double points. There to there, space bar. 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 Last one, there to there. Okay, so now we have our ID drawn, pretty much everything, except for the fillets and chamfers. So let's get out of this menu here. And it looks like we have 1, 2, 3. We actually have this one drawn in, so we already have 1, 2, and 3 right there. I think that's all of them. Yep, so let's just pick the points there. So this point, hold the control down. Okay, and this point here, and this point here, and pick on this little icon here, which is chamfers. Make sure you're on chamfers. And we want 1/8 of an inch. And we'll just pick, yeah, that's all the chamfers. So let's stay in this menu anyway. So let's do that. So now we have our chamfers there. So now we need to go to fillets there. So let's click on fillets while we have this open. And this needs to be 1/4 inch. Let's do the 1/4 inch ones first. So 1/4 inch, 1/4 inch, 1/4 inch, 1/4 inch, and I think that's everything. So make sure you're on fillets. This time 1/4 inch. Just press enter and you'll see those all appear there. Now the last one we need to draw is this 3/4. So let's just pick on the corner there and type in 3/4. You can see it's not giving us a radius in there. And so you're probably wondering, why isn't it giving us a radius? I picked the right corner there. That's because this radius, of course, can be tangent to here. There's enough room, but this is smaller than 3/4 of an inch. So if we were to dimension that, you would see why it is. So if I dimension that, you'll see it's exactly 3/4 of an inch there to there. So you can't have a radius attached to this line here and still be 3/4 of an inch. So we need to delete this line here. So we'll get rid of that. Let's turn off our dimensions for the moment. And we can get rid of this point here. It's just a point in space now that we really don't need. Okay, now we need to draw a circle. And you don't need to pick any menu. Gibbs knows what you want to do, but we would know we want it to be tangent to this circle and tangent to that line. Then it asks for a radius, and that'll be 3/4. It gives you all these choices of tangency. Select this one, of course, and click OK. Now our part is fully drawn using just geometry, lines, arcs, circles, and that. I think we have everything drawn in there. Everything looks pretty good. Chamfers, fillets, everything looks good. So that's another way to draw it versus parametric. The next class will show you how to bring this geometry up using a solid model, which you'll see like in 5 mouse clicks, you'll have all the geometry. So the advantage of using solid models, but this is just learning how to draw with geometry. So I remove the print. Now we're going to create the tools and start machining this part. So I'm going to bring in the tool list here that I've already created there. We'll just go to tool list, browse, pick the tool list for this, and it's going to load those up, and then we'll go through all the tools. So the first tool I want to use, standard like CNMG, 1/2 inch inscribed circle, tool holder sitting in the turret this direction, offset number 1, and spindle forward. So that means the insert is facing to the back of the machine, so it'll throw the chips to the back. You can see if I go reverse, you can see the insert's facing up now, which will throw your chips to the operator, which you usually don't want to do. So let's make sure that's back on forward. And I usually give it a name, main spindle, rough, and what I'm doing with that. So when it's out on the control, the operator, whoever's running it, can look at the text and see what that tool is supposed to be doing. Okay, everything else there looks pretty good. Okay, next tool, It's going to be a 55 degree there. We're going to use this for somewhat finishing and somewhat roughing as well. Even though I have finish face and OD, we're going to use a different tool, and I'll show you why as we get going there. But same location, 1/2 inch IC, tool holder, and 5 degree face relief. Next tool is going to be our static tool. That's going to be 1.187. And if it's like an insert type drill, depending on the angle of the drill and the type of tool you choose, I just put 175 degrees, which some of them are almost flat at the front. So of course put in the angle that you actually have for your tool, and that'll be correct. So make sure it's sticking out of the part long enough. Everything else here, give it a name. Next tool is going to be the boring bar. You can see you can scroll down in here and look at the different shanks. Now if the shank is bigger, or the minimum bore is bigger than your ID, then Gibbs is not going to let it go in. So make sure you choose that correctly. Look at the shank diameter, look at the minimum bore to make sure that's going to fit. Otherwise you won't get a tool path on there. So the next tool, tool number 5, is going to be a 35 degree. This is going to be our actual finish tool to finish the face and the OD. And last tool, just a threading tool. Choose the style you want and the threads per inch if you want. If this is a form tool, you could of course choose just a V tool. If you just wanted it to be any angle you want on there, you could choose a V tool instead, down right here. But this is going to be a kind of a form tool. So when you have form tools, it asks you the actual thread, so it can form that a little bit better. Whoops, that needs to be UN, sorry. And that's 12 threads per inch. Let's go back to that, make sure I have it correct. Now you'll notice on here, if I zoom this up here, this little arrow right here means this is basically where you're going to touch off the presetter of your part. Normally I like to start right here on this little X here. So I touch the edge of the insert off your presetter so it sets the distance in Z here. And if I look at the code for the machine, if I'm machining up or threading up to a shoulder and I don't want that shoulder to hit the wall, I know that I programmed it from this edge here. So if my wall is -1 inch and I'm going at -0.990, I know this edge of the insert is not going to hit the wall. So you can choose either here or here. I usually like to touch off here. Okay, so the first thing I want to do is, of course, face off the part. Let's turn on our cam, and we're going to rough this out because I don't want to take 1/8 of an inch all in one cut. So let's bring this up here, and we want to do a roughing pass with that tool number 1. And we're going to do front face. There's our rapid 2 there. I want to go, we're going to go 50 thou depth of cut. Finish stock, I'm going to leave 0, and Z stock, I'm going to leave that at 3 thou. And depending on the material you choose, you can choose entry and contour feed and surface feet per minute. It'll fill in the blanks. If you don't like those, you can always go to material and you can edit these, and that'll be saved in your database for future use. I think everything there looks good. We want a can cycle though. I wanted like a G72, and we have to make sure we're on full, or otherwise it won't let us do prefer can. And there's prefer canned. Everything else there looks pretty good. Okay, let's close this. One thing I might do is put a point. Let's just draw a point at 0, 0. And we'll show you why here. So let's click on the front face here and OD there. And if you want to go to a specific OD, you can right click and say move it to a certain diameter there. Okay, and we're going to go down in the Z, cut on the outside, and let's put the black round pointer right at X0Z0, and it'll snap to it. That's why I put a point there, so it makes it a little easier. Click on do it, and now we have our facing operation. So the next thing I want to do is the OD of the part. Cut the OD, so I'm going to use the same tool, same process. I'm just not doing a facing operation. I'm doing OD. We're going to go 1/8 of an inch. That's XR, so that's radius, so 1/4 inch diameter total. And this is our rapid move, and we're not at 2.5 inches. That may have been from a previous part. Our part is going to be 8 inches. That's where the actual material is. And again, we want to leave a little bit of stock, so I'm going to leave 10 thou on the XR. That's 20 thou total on the ODs, and all 3 thou on all the faces there on the Z. Everything there looks pretty good. Now, one thing I'm going to show you as I do this, let me zoom this up a little bit. Okay, I'm going to click on the chamfer there, and you can either drag it off the part, right click, or say move it off the part 100 thou. You could do that if you want. That'll move it there. Now, the best way to get the black square one over to the last thing you want to cut is just to do Control-Shift and put it there. Now, remember, our jaws are up here at 5/8, so what I might do before I do this is put a point so I can snap to it, so I don't go past that to hit the jaws. So I'm going to do point and point at an angle. Let's turn off cam for just a minute, and I want to go from here, and I want to go distance 1/2 inch, and it'll be 0 degrees. So there's where our jaws are actually at. Remember, we're grabbing onto the part 5/8 of an inch, including the 1/8 inch back there, so that's 1/2 inch from there. Okay, let's turn our cam back on, start over again there, drag it off the part, Control-Shift this line, and probably want to stay. I maybe should have put another little point ahead of that just to make sure, but I'm going to click on about right there. Actually, I could actually stay closer to here if I want, because this is already a size. Then click Do It. Now, one thing you'll notice, let's run the rendering on this to see what we've done so far. So we'll slow this down. So we're facing this off, and we're cutting the OD. So far, so good. Okay, the only problem that I have here, let me turn on the geometry, is this section right here. Most controls will not let you do a can cycle if you're going from small to big, then back down to small. You usually have an alarm on your machine saying it can't do that. So you could machine this longhand, have longhand code, but I like to use can cycles because it's much more efficient. So let's fix this. So let's turn off that, and let's open up our process again. And this time we're going to tell Gibbs, don't do any more X minus moves once you've gone up. And then, of course, we're on this operation number 2, so click on Redo. Now you'll see that doesn't dip down into there. Now, as before, Gibbs would let it dip down in there because it stays, I think it's 2 degrees away from the insert, so it'll allow you to go down there if you want to use longhand code, but I like can cycles. It works much better. So let's render that again. And you'll see that looks pretty good there now. Okay, so before we finish roughing this out and finish it, I want to at least rough out the ID because of stress relieving. Okay, so next, clear this out, and let's bring up a drilling process. This is going to be, of course, static drill, 1.187 drill. So 1/4 inch away, I think, let's see what we have here on our document control. I have actually 3/8 there, so I'm going to change this so everything's equal. 3/8 there. We've already faced it almost off. You could put in 3 thou there, but it's really not going to make much difference. So now you can, let me move the part over, and let's highlight the full diameter of the drill and hold the Alt key down and click on the last thing you want to cut, which is -7 inches. But remember, we have an 1/8 of an inch pass there, so I'm going to go minus, we'll put 7.2. That'll get it clear past our part there. And of course, feed in, wrap it out, depending on if you have coolant, high pressure coolant or not. That's up to you. If you want to peck it, that's of course totally up to you as well. Then you of course should do your feed and plunge. And you don't need to pick any geometry because this is a static tool, so it knows it needs to be in the center anyway. So just click on Do It. Now we have our hole drilled in our part. Okay, almost to size. Next, clear this out. Bring in a roughing process again with our boring bar. This time we're going to do a front ID, and we already drilled the hole 1.187. That's where we want it to rapid 2 and rapid 2 when we're done. And there's the material that the drill left over or starting 1.187. We're going to cut this down to probably 80 thou per rev. Everything else there we're going to leave the same. A little bit of stock, feed rate, make sure all these are on. Prefer canned. Okay, let's start here. Let's go this direction. Let's just right click the white round one and say move it off the part, 100 thou. Okay. All right, let's hold Control Shift. Sorry, I missed that. Let's do that again. One more time. Okay, let's do 0.1 again. All right, now we're good here. Okay, now Control Shift. Click on the last line there you want to cut. And we'll go a little bit past there. And click on Do It, and there's our roughing. Okay, now we're basically ready to finish. We've cut most of the material off, so we shouldn't have too much stress relieving. So I'm going to clear this out and just bring in a contour. We're not going to use multiple process, otherwise we could have done this with one shot, but we're going to do this since this is the first part, one tile at a time. So again, front ID, this is the same tool, 1.187 is where we want to wrap it to, but I think I want to get a little bit closer to the part there. So I'm going to highlight this button here, hold the Alt key down, click on right there. You can see it's 1 3/4, so I'm going to start right at there instead of going to 1.187 and then feeding up there. So you can get closer if you want, or you can let it feed up however you'd like. We're cutting everything to size there. Everything looks good there. Okay, again, we're going to start off our part a little bit this direction. Control Shift, a little bit past there, and we'll click on Do It. That'll be our finish pass. Make sure you click on the ID, which I forgot to do. Click Redo. There's our finish pass. Okay, so far so good. Let's look and see where we're at. Okay, let's rewind there so we get everything correct there. Okay, drill, rough, and finish. Okay, everything's good there. So now we need to finish, kind of rough out the outside a little bit of this groove, and then we'll do finish on there. So let's clear this out, do a roughing process with that 55 degree. Actually, we could use the 55 degree instead here just to rough it out. That'll be fine. OD this time. Zoom this up just a little bit. We don't want to wrap it to 8 1/4 clear up to there, so let's just highlight this button, hold the Alt key down, click on this line there. You can see it's 2 1/2. I don't want to wrap it to there, so I'm going to go 2 5/8 and 2 5/8 when we're done there. And the material, highlight that, Alt. The material left over is starting at 2 1/2 inches. This is 55 degrees, so I'm going to go 35 thousandths depth of cut. We'll just do a finish stocks with leaf stocks everywhere. We'll do 5 thou everywhere there. Do our entry and exit feed there. 12 is a little much. Let's go down to 8 thou. Okay, everything there looks pretty good. We can't use really a can cycle in that. Let's go material only and tell the tool to stay away by 50 thou. So I'm going to click on this chamfer here, bring the tool out just a little bit to the starting point, hold the Control Shift down. Let's just end on this line here. Since we have material only, it's only going to cut where material is left over. So then click on Do It. And there's our path there to cut that. Now you'll see when I render this why we chose the 35 degree to finish. So let's finish that. We need to rewind to make sure we get everything correct. Now you can see the 55 degree is not going to clear this here. So that's why we need to use the 35 degree to finish. And this isn't too much there, so we'll just finish with that one. If you wanted, you could have roughed it out with 35 degrees instead of 55. That's, of course, totally up to you. Clear this out, do a contour with that 35 degree. We're going to do OD, but I don't want to start at 2 5/8. So basically want to start basically a little bit underneath here. So I'm going to highlight this, of course, hold down the Alt key, click on right there, and you can see that's 1 3/4. I'm going to go just a little bit below that, so I'm going to say maybe 1 5/8. And of course, when we're done, I want to go to 8 1/4. I think I put on their clearance plane before. And we'll do a little bit of a 90-degree line, 50 thou coming in. And we're going to basically back face this. So I'm going to say 6 thou on there. And you can type in your entry and entry feed or use the material only. That's up to you. Let's click on the face there. And we're going to start a little bit below there. Go this direction. Hold the Control Shift down. Click on the last line there. Actually, I probably want to end on the chamfer there. And a little bit past there. And we'll click on Do It. Now we should have our finished shape there, so let's render this. And there we go. And it matches our geometry perfectly along with this angle there. So the last thing we need to really do is turn off that, is do our threading here. So let's clear this out. Choose a threading process with that form tool. Okay, we're going to do it from parameters there. Constant threads per inch, 12 inch. That's the pitch. This is 2.5 inches, so I'm going to stay a little bit above that, 2 3/4. I'm going to stay 1/4 inch away from the end. Most machine tool manufacturers recommend at least 2 threads in front of the part before you engage the threading cycle. So 1/4 inch should be plenty there. And of course, this dimension here, I'll just put 0 there. Highlight it again, and I want to go right about to there. It's good. So that's 1 5/8 back. We're doing a Z minus, so from the right to the left. OD, 2.5 inch, just a single start. So this is a single entry thread. It'll figure out the major, minor diameter. You can put in whatever speed, RPM you want, or use the material only if you want it to calculate for you automatically. Now you have a choice of balanced and angle. I'm not a real fan of the angle there because sometimes I see it leave steps in there depending on your machine tool. So I like to go balanced and go right in the middle there. That seems to work pretty good. So depth of cut, this is the first cut here. I have 25 thou. And last cut, we'll just uncheck that. I want to do constant load there. If you want to do a spring pass, you could put something in there if you'd like. And can cycle, so everything else looks really good. So let's just click on Do It. You don't need to select any geometry because Gibbs already knows what you want to do. And let's click on Play. Let's rewind everything there back right from the beginning. Roughing, finish. Then threading there. Screen may flash a little bit just because I'm recording there. But that's your finished part there. Of course, you can do a full half cutaway, full OD there. And again, 1/4 cutaway, which is what we had, and half and back to full. Now we don't want to go too long on this, but we're not going to do the back side of this part, but you can easily do that if you like just by let's do a save, and then you could do a save as and maybe say op number 2. So basically all you need to do, turn off this here, is grab your part once you've changed the name and just do mirror or rotate, either one you'd like to do. You could mirror it, and then you'll have all the geometry ready to go this time, and then just do the back side of there. So anyway, this is how you do the 2-axis turning using parametric or geometry. And the next one will be going off of a solid model, and you'll see the difference between there. So that'll be in the next class. So thank you very much for watching.